Do you know what Pearson's correlation coefficient does?
No, I know how to find it, but I don't actually know what it is.
Okay. Do you know what correlation is?
No.
Okay. So when you've got when you've got an x coordinate and you've got a y coordinate, and then they might not necessarily be called x and y. It could be like distance and time. Could be time and cost, for example. Could be cake sold versus how much money you make. Can be all sorts of things, right? It doesn't necessarily have to be x and y, right?
Yeah.
Height, weight to age, height to age, like whatever two things you're comparing.
Yeah.
Going to be on the x-axis, the other one's going to be y on the y-axis.
Yeah.
If they were related to each other, if they kind of had some sort of relationship with each other, they would be correlated, double R. Okay. Now, what words do you see in correlated, or what two things do you see in correlated?
They're related.
Yeah, you see related and you see co, right?
Oh, yes.
Yeah. So co means together, right? So cooperation, company, right? And related means that they've got some sort of relationship with each other, right? So that means that if two things are correlated, it means whatever's happening on the bottom has some sort of relationship with what's happening along the side. Does that?
Mm-hmm.
So if two things were perfectly correlated, they would work together.
Form a strong, positive.
Yeah. They would work together to form some sort of identifiable relationship. Does that make sense?
Yeah.
And you've got like a straight line. That means as x goes up, y is also going up at some sort of a rate, right? Mm-hmm. So when you've got a straight line that's really, really clear, right?
Yeah.
Then we can say that it's perfectly correlated. Okay?
So when you're finding out Pearson's correlation, like the number, what is that? So that's if it's like 1 minus.
Yeah, I'll get to that in a moment.
Okay.
Right? So do you see how that's perfectly correlated?
Yeah.
Yeah. And this is also perfectly correlated. It just so happens that there's a different relation, but it's also still perfectly correlated. Right?
Yeah.
Okay. The lines, the steepness of the line is different. It is different, but that doesn't mean that they're not correlated, right? Mm-hmm. Correlated perfectly. Now, imagine if the line wasn't so defined. It kind of looks like it's a straight line, but it's not quite a straight line, right? Something like that, okay? And your line of best fit's going to kind of look something like this. Do you see that?
Yeah.
Right. So that's not perfectly correlated, but it's close.
Yeah.
Yep. So it's less correlated. Got it?
Yeah, got it.
Okay. Now, can you also imagine a situation where things were less correlated even still? Okay. Yep. That means that each of these points is going to be further away from the straight line that ought to be the perfect relationship.
Yeah.
Yes, right? So you got something like this happening, and right? So that's less correlated even still.
Yeah.
Okay. And then you've got total chaos or total randomness, and it just doesn't look like there's any straight lines.
That would you say that has no relationship? That
has no relationship. Got it?
Yeah.
The correlation coefficient, which is the letter R, Pearson's correlation coefficient, right? Which is the letter R. Coefficient just means number, by the way.
Yeah, okay.
Special word for number. So where you've got Pearson's correlation coefficient, where it's totally random, yep.
Yeah.
Got a correlation coefficient of 0.
Okay.
Okay.
No relationship.
Sorry?
There's no relationship.
Yeah, absolutely. That's correct. Where you've got a correlation coefficient where you've got a relationship that's perfectly linear, right? Perfectly a straight line, then that's a correlation coefficient of 1.
Okay.
Positive 1, right?
Yeah.
And then in between, right, the closer it is to being a perfect straight line, the closer it's going to be to 1.
1, okay.
And then the less, the less like a straight line it is, and the more random it looks, the closer it's going to be to
0.
0. Does that make sense?
Yeah. And then if it's positive or negative, depending.
Yes. So if you had your straight line, but this time the the perfect correlation was a negative line.
Yeah.
Okay. So it's kind of instead of y going up as x goes up, right? As x goes up, y goes down, right? So that's what we call a it's still perfectly correlated, but in the other direction.
Okay.
And so what happens is that in this situation, your correlation coefficient, instead of being positive 1, is going to be?
Negative 1.
Yeah, absolutely. Got it?
Yes, okay.
Yeah. And so if we had a situation that looked like this, but instead it was going in this direction, it might be a correlation coefficient of 0.7 or, negative 0.7.
Yeah.
Okay. Yeah. Whereas this one would be, say, positive 0.7, right?
Yeah.
And so if you had a correlation coefficient of, say, 0.5, that's kind of halfway.
Yeah.
Perfectly straight line and perfectly random. Okay. And so if you had a correlation coefficient of 0.6, would it be closer to being a straight line or closer to being random?
Closer to being a straight line.
Yes. And if you had a correlation coefficient of 0.01,
weak.
Yep, it would be weak. It would be more random.
Yeah.
So that's basically what correlation coefficient does.
So when you have like the set of data and you put it into your calculator, like it's in a table,
yep.
And you find R, which is the correlation coefficient, that's just giving you that number.
Yes, that's just, yes. And what does that number tell us?
The relationship between the two.
How closely related.
Close.
Yeah. Does that make sense?
Yes, okay.
Yes, absolutely. Cool.
So it's just when you put it in your calculator, it's giving you that number. Okay.
Yes, you're smashing it. And okay, so now imagine you've got a set of data. Okay? Yeah. Now I'm gonna put that data in red. Okay. So just say, we'll use this one here. Just say your data is like that. Okay. And then maybe another couple on this side. Okay, cool. So where is your, so if this is your red data, like this is all the data we've collected, right? That's the cluster of data that we've collected, right? Where are the two endpoints of the data? It's between here and here, isn't it?
Yeah.
Okay, so that's A and that's B. Got it?
Yeah.
A and B, but let's just call it A and B.
Yeah.
Right? Now, we have to find, and I'm going to do this in blue. We have to find a point, right? We have to find what the Y value is, right? The Y value, which is this one here, based on an X value of C, okay? Right? We try the best fit, and C should be somewhere around here. We're trying to guess where our Y value would be when our X value is C.
Yeah.
Now, is that in between A and B or outside of A and B?
Inside.
Inside. So it's in between A and B, right?
Yeah.
So this is what we call A. You want to have a guess? Starts with I.
Interpolation.
That's right. That's called an interpolation.
Interpolation.
Why do you think it might be called an interpolation? Have a guess. I reckon you'll get it.
Because it's in
between?
It's in between the range.
Yeah, it's in between A and B.
A and B.
Good. Now, I'm going to get a different color pen, this time orange. This time, we're asked to guess, right, or asked to estimate what the value would be when X equals to D, right? So we take our line of best fit, and it's going to be somewhere here. So our Y value is going to be somewhere here, right? So we've now, from the line of best fit, right, estimated what Y would be when X is equal to D. That in between A and B, or not between A and B?
Not. So it's extrapolation.
You're one step ahead of me. Awesome. Do you get it?
Yeah.
So that's called an extrapolation. Okay?
Yeah.
Yeah. So what's the difference? Now, in your own words, I want you to tell me what's the difference between an interpolation and an extrapolation.
Well, the interpolation is when it's in between the range of the data. That's given, so it's in between the A and the B.
Yep.
So when you've given the point, like when you've circled, when you've given the X value to find
yes,
that's not the data you've collected.
No, that's not the data you've collected. That's basically your best guess of what the answer would be, or what would be, based on the data that you have collected and the degree of correlation that you've, does that make sense?
Yeah. So the interpolation is within your data, within the range of the data that you have on the graph or you've collected, and the extrapolation is outside, like not within the data.
Yeah, perfect. You got it.
So what's the point of finding the interpolation and the extrapolation?
Okay, so for example, I'll give you an example, right? Just say, this will be a really good example. Just say, for example, you're doing a maths assessment at your school, okay? And the set of scores at your maths at school is, these are the scores that people got, okay?
Yeah.
And just say, for example, so along this side is the scores that people actually got, okay? And on this side, this is the scores that people got in the last 3 assessments, right? The average scores that people got in the 3 assessments. And what you notice is that there's a certain degree of correlation, okay? But you were away for that assessment. But you were actually there for the last 3. So we know along here that you're probably sitting at this point here, right? Because you didn't sit the test, we don't know what you would have got. So what we can do is interpolate what you would have got based on everyone else's scores.
Yeah, okay.
Does that make sense?
Yeah.
And so that's an application of where you might use this, right? Because what you can do is you can work out, well, if people, based on what people have got in the last 3 tests, right? And what people got in the most recent test, we can find a best fit. And anyone that was away, we can interpolate or extrapolate what they would have got if they were there. Yeah.
And they would have definitely interpolate because it was within.
Yeah, that's if you're a mid-range student, yeah, probably.
Okay, right.
But if you're like the person who always comes first, and then that would be an extrapolation.
Yeah. Okay.
Does that make sense?
Yeah.
Yeah.
Right. Okay.